Welcome, game developer hobbyists! Since my last video, I've completely redesigned the source code for our classic game of Pong. The redesign has been tagged in my GitHub repository as Pong 120. As we see here, along with the redesign, I've also improved the appearance a little so that we can see the walls and out-of-bounds area. The primary goal of the redesign is to provide more flexibility to add features to the game. This includes eventually adding game options such as ball speed, paddle length, and play against the computer. In my last blog post, I planned out some of the structures I felt I would need. This diagram shows the enums, structs, and classes that I ultimately decided upon. First, we'll talk about this game client class. This represents our Pong game from the moment it starts running to the moment it's closed. The calling code will still handle initializing the window and game loop, but will delegate to the game client object to update its state and draw to the OpenGL context. The client mode enumeration is used to keep track of the current state of the game. As of this commit, only the match running value is implemented, but it will be fairly easy to implement the other three game states. Initially, the match definition struct is just set up with constant values for the court size, paddle size and speed, and ball size and speed. The plan is to eventually allow this to be modifiable through game options. Also note that I've split things up into a separate match and match renderer class. This is to provide a separation between the way the state of the match gets updated and the way the game is displayed on the screen. I felt it was important to keep these separate for several reasons. First, I feel it will help keep all of our code related to rendering in a single place. Second, it allows for future visual improvements that might not be kept as part of the current state of the match. Imagine, for example, that we wanted to perform an animation on the screen when the ball hits a wall or paddle, or when the score is updated. In such a scenario, this information would be returned by this match update result struct when performing an update to the match. This would then be passed along to the renderer to decide how to display this to the user over however many frames it needs. The match input request struct is used as an abstraction to indicate the player inputs. At the moment, it just indicates which direction each player is requesting to move their paddle. The main reason I felt this abstraction was important was to eventually handle AI-controlled paddles. The court collision check util class is used to determine what all happened with the ball in a single frame. If the ball is moving quickly enough, it's possible it can hit both a wall and a paddle. That's why the result is organized into a list of collision results and the final position and direction. At one point, the algorithm for this attempted to use a generic check for where two line segments intersect. I found this to be more complicated than it needed to be. It also had difficulty when the ball struck a barrier at the exact endpoint. The revised algorithm essentially keeps checking for collisions until the full length of the ball's path runs out. I felt that placing this in utility class was important for two reasons. First, it allowed me to test the code in isolation from the rest of the Pong application. Second, I'll be able to use it later to assist an AI-controlled paddle make decisions about where the paddle needs to be. So with this complete refactoring in place, my next step is to move forward to adding game modes and game options.